We got to get it into, that's perfect, standard form. Okay, so remember standard form means, and I'm going to rewrite the original problem over here to the side. Remember standard form means that all three of these terms need to be on the same side of the equal sign. So that means that minus 10a needs to be over on the left. So how am I going to cancel out that minus 10a over on the right-hand side? What cancels out a minus 10a? A plus 10a, right? So I'm going to add 10a. And you're right, ma'am. I'm going to add it to both sides. Okay, so now on my right-hand side, it's going to cancel out. Yeah. Alrighty, sorry about that. So over on the right-hand side, that's going to cancel and leave me with a 0. Okay, because there's not nothing there. There's still a 0. And obviously, we cannot combine an a and an a squared because they're not like terms. So all we're doing is rewriting the left-hand side of the equation. So it's 2a squared plus 10a minus 48. And as I said yesterday, I've got a lot of people in here with excellent number sense. So you guys might not necessarily need to do that step right there. You might just recognize in your head that, oh, if I move that negative 10a over to the other side, it becomes a positive 10a, but the rest of the equation remains the same. So if you're one of those folks that can do that in your head, you don't necessarily, especially in algebra, they're going to appreciate if you can do steps like that. But that's why that 10a became a positive 10a, because we just added 10a to both sides to move it. So now that we've completed step 1, it's in standard form. Step 2 is define that GCF. Remember, what can I divide 2a squared, 10a, and 48 all by? 2, exactly. So we got 2 times a squared plus 5a minus 24. Remember, the whole point of doing that is that now it's easy to find the zeros because we don't have big numbers like a minus 48 and a 10 anymore. We've got much smaller numbers to work with now, so that when we go to factor it, we've got easier numbers to work with, which takes me to my next step. Remember, to find my zeros, I need to break apart that trinomial into 2 binomials. The only way to get a squared is to do a times a. And then I'm going to set up my chart over here to the side. What am I going to multiply to get negative 24 that will add together to get 5? So by doing guessing and checking, I figured out that 2 and 12 get me 24, but they aren't going to get me 5. What's something else?
6 and 6.
One of them has to be negative.
Ooh, I like that. So one of them has to be negative, because the only way I could get that negative 24 is if I multiplied a positive times a negative. So that's going to be a negative 8 and a positive 3. Because negative 8 times positive 3 multiplies to 24. And if you add them together, oh, wait, I'm sorry, I did it backwards. It should be a positive 8 and a negative 3, right? Because that's a positive 5 in between. Sorry about that. I did it backwards. So that's a positive 8 and a negative 3. Because positive 8 plus negative 3 adds up to positive 5. And it multiplies to get to negative 3. So that's the one I need. So it's a plus 8 and a minus 3. So remember, to find your zeros, you're trying to figure out what values for a would cancel out a positive 8 and make it a 0. What's the opposite of positive 8? Negative 8. So, and what's the opposite of negative 3? Positive 3. So I'm pretty sure that my zeros are negative 8 and positive 3, which means if I go over to the graph, and a couple of them, guys, I did goof. I totally forgot that some of them came out to be 8, so I didn't give you enough room on the graph. I'm sorry, I suck. But just kind of scooted over a little bit. Assuming we did it right, that means in a second, I'm going to put coordinates on the x-axis at negative 8 and positive 3. Here's how. So I've done all that work by hand. Now I'm going to use my graphing calculator to double check, make sure I did it correctly. And I'm going to show you how to do that now, how to get those zeros. So we are going to type into the calculator the equation in now. Everything has to be over for your graphing calculator. It all has to be over on the same side of the equal sign, the same way that we rearranged it. So we have to put it in there so that that 10a is over on the other side. You can't put the original equation in. Okay, so what we're going to do is you click y equals. So everybody should be clicking y equals 2. I'm not going to click, I'm just going to use x in the place of the a because the variable really means the same thing. So again, I'm going to do y equals 2, my alphabet soup to get a variable. And to make that a squared, I'm going to hit my little caret button to raise it up. And 2. Is there anybody that needs to see where the 2x squared came from again?
Yes.
No problem. I know this is new. Most of my goal today is just to get you used to the graphing calculator, so no sweat. Okay, so I clicked y equals, which is how I got here, 2, alphabet soup button to get a variable, and then I raised it, hit the little caret button, to the second. Anybody need to see that part one more time, or are we good? Okay. So now notice that my blinking cursor is up there by the 2. So I need to get it, if I do the rest of the equation, it's going to be up there next to the 2, and that's not where I want the rest of the equation. So I'm going to hit this arrow to the right to get it down. And what do you think I'm going to hit next? I need that 10a. Now when I moved that 10a over to the other side, is that a positive 10a or a negative 10a? When I moved it over, it became a positive 10a. So that's what I'm going to type into the calculator, not the original problem, okay? The rearranged version. So plus 10x, which we're just using in the place of a, and then the minus 48 didn't change, just minus 48. Is there anybody that needs me to do the equation for them one more time? Do we feel okay about it? Okay. So then we're going to click graph. So, I'm sorry, ma'am, what? How'd I get X? I hit this little alphabet soup button. See the one that has the XT right there? Mm-hmm. That button gives you X. Okay. So once I hit graph, remember the zeros that we thought we got were what? -8 and +3, right? Mm-hmm. So if we're looking here, that looks about right. It looks like it's about -8 and +3. Sometimes the graph scale is misleading on the graphing calculator. Lord knows that's little, right? I got somebody right now sitting there trying to count, like that's hard. And assuming that the scale is right, so let me show you another way that you can verify it. So what you do is you hit second, and see above the graph button, there's the word table. So you're going to hit second, and then the graph button, because it's getting you to the table. So again, I did second, and then I did graph, because I was getting the word table above it. And it gives me a table of values right there on the graph. So if I graph those zeros, so we think that they were right here at 2 and over here at -8, right? Notice that the y value is 0, because the only way that those two numbers can be on the x-axis, they have to be right there at 0 on the y. So I'm going to look on my graphing calculator. Notice right here on the calculator, there is a 0 underneath the y. What value is sitting right next to the 0 on the y? What value for x?
3.
Yeah, there's a 3 right there, look. So again, so you guys can see where I'm getting this from. If I look on my table, notice right there, y is equal to 0. That's why they call it the zeros. What number for x is next to it? 3. Did we graph a +3 already? We sure did. So now let's see if we've got that -8. So what we need to do is just scroll up on the graphing calculator until we see, because we think it's -8. So obviously I'm at -1 for x right now, right? So let me scroll up. Look, -8 and y is 0 right there next to it. So if you've got a 0 in the y column sitting next to the number that you think is the x, the 0, you know you did it right. So I looked on the table. I've got a -8 sitting next to a 0. And then I've got a +3 sitting next to the 0. So I know for sure that I did it correctly. I've done it by hand, and I verified using the graphing calculator. Okay? So your task